Okay. So when you are running your system, there will be certain problem because of foam creation. If paraffin may create problem, sand may create problem, and there will be two terms, Blowby and carryover. I'll explain. So what is foamy crude? So foamy crude is this: if we have paraffin, asphaltene sort of impurities, and if you have maybe viscosity higher, so in that case a foam will be created. Let's say you have separator and liquid and gas interface is this one, and foam means like small gas bubble coated by liquid. Okay, let's say this is gas out. Okay, okay. So if I have lots of foam or bubbles not joining together because of certain chemical and other reason, so this is taking certain space, right? So actual separation space got reduced. Okay, so because of foam reduces separation space. Separation space. Okay, large volume to weight ratio, large volume to weight ratio. Okay, so volume is higher than weight. Okay, so it will create one froth over it, and that will what is the problem? Problem is that if level control is there, level control will be working because of certain the level control on balls or buoyancy floating device will be there. That floating device will be working if fluid viscosity, fluid gravity and this gravity is properly matched. It is not matched properly because you created foam. So actually your gravity of foam is different than the actual liquid. Then your level control of the ball will be floating how much? So it will be creating wrong signal. Okay, so when it is creating wrong signal, so liquid out valve can be opened before required time or after required time. Okay, uncontrolled foam bank, impossible to remove separated gas or degassed oil from the vessel without entraining some of the foamy material in either liquid or gas line. Okay, so this gas line can get some foamy material, some bubble particle, or liquid line also can get some foamy material. So both cases it is a problem. So you have to remove foam, then you can get your liquid out or gas out. Okay, so in some cases you can use foam depressant or chemical, in some cases you can use that mechanical arrangement, defoaming plates. Paraffin. Paraffin actually at certain temperature it will be solid. Okay, if you increase temperature it will be in liquid form, but reduce temperature it will be hazy mass, it will create cloud or small particles that will be blocking everything. Okay, so coalescing plate, mesh, everything gets plugged because of paraffin. Coalescing plates means particle will be growing together, mixing together, making diameter larger. So this coalescing plate. Okay, or mesh or this defoaming plate or anything, they will get plugged. If known that the paraffin is a problem, centrifugal mist separator can be used. Okay, or because at high rotational speed you can separate the solid also or paraffin also, or you can increase the temperature of the system so that paraffin will not form solid. So create liquid and you move from separator to another place where you can separate paraffin separately. Okay, you can handle separately, but you cannot take paraffin in every separator. So increase temperature, remove one by one, then maybe in certain stage you can remove the paraffin, that will be okay. Sand. Again, sand also one biggest problem from beginning I am discussing. The sand particles will be hitting the metal surface. When it is hitting metal surface, it will be eroding actually. When small sand particle hitting metal surface, one particle, another particle, two particle, three, 1 million particle, 2 million particle hitting, so metal particle surface will be erased gradually. Okay, when metal surface is getting erased and if you have corrosive fluid, so erosion and corrosion will be occurring. So, erosion and corrosion. Corrosion needs some fresh metal surface and corrosive gas. It will be reacting, it will be creating salt, let us say iron plus H2SO4, iron sulfate, that is softer material, and sand is there. So, sand will be removing the iron sulfate. When sand remove iron sulfate, again fresh metal surface came up, again the acidic gas will be reacting on the metal surface, create salt, sand will be removing that one. So, continuously this erosion and corrosion will be occurring. So, your metal surface will be eroded. Another issue is that it will be getting deposited in your valves, chokes, separator. So, that will be a problem. And again handling sand on the surface, if you have larger amount of sand, so you have to remove all the hydrocarbon particle, then you can dispose. So, it is having multiple negative impact on your surface separator system or oil and gas production systems. So, you have to handle that one properly. Okay. So, it will be creating plugging, it will be accumulating inside material, pipes, tubes, valves. And one thing is that special hard trim can be done so that erosion rate can be reduced to minimize sand effect on valves. Accumulation of sand can be alleviated by the use of sand jet and drain. So, sand jet you can create and can forcefully remove the sand particle from the separator systems. Blowby. So, blowby actually free gas escapes with liquid line. Okay, can be indication of low liquid level. So, let us say you have one separator system and your oil liquid out is there, liquid line, okay, and your liquid level is here. Because of certain reason your liquid level gone down this level and it reached to exit end. So, what will happen? So, this will get certain amount of gas. So, you have to avoid that one. Okay. This is stopped by level safety low sensor. Okay, some sensor must be there. So, if level is going below certain limit, then you must stop liquid out. Okay, your valve should be closing the flow path, so that liquid level again it will be going up, then you can remove the liquid from the separator. Okay, when liquid level drops 10 to 50%, 10 to 15%, 10 to 15% below certain limit, then you have to stop dump valve, again allow to build up liquid level further, then open liquid output valve or dump valve. Then things will work like this. Okay. Another carryover. Carryover occurs when free liquid escapes with a gas phase. Okay. Free liquid escapes from the gas phase and can indicate a high liquid level. Can indicate a high liquid level. Okay. Damage vessel internals, foam, improper design, plug liquid outlet, or flow rate that exceeds the vessel design rate. So, that will create liquid carryover through the gas line. Okay, before you discuss further for separator designing, we should know about settling. Settling means a particle falling down, okay, and gas is moving up. Gas is moving up and let us say liquid particle falling down. Okay. So, because of liquid particle is falling down and gas moving up, there will be drag will be acting on it, okay, and liquid particle falling down, there will be buoyant force or net force downward, it will be working. So, if we know the terminal velocity, based on the terminal velocity we can calculate further your separator sizing, let us say seam to seam length or diameter we can get from it. So, retention time. Good morning, we will discuss today two-phase separator, and the basically topics will be like particle settlement, droplet size, retention time, re-entrainment, gas capacity based calculation, liquid capacity based calculation, for vertical separator, for horizontal separator. So it will be more mathematical. Okay, previous lectures were there based on more theoretical part, but we will go towards more derivation and mathematics. Let's say first assume horizontal separator like this, and we will be assuming 50% liquid. Okay, 50% liquid. You can assume different type also, but 50% assume liquid we are assuming because we are getting more surface area if you have 50% filled. Okay, if you see side view of the separator, 50% means you are getting more this, let's say this is D. Okay, and if you are filling 60%, 70% or 30%, 20%, so in that case your interface area, gas and liquid, will be lower. Okay, but in your separator system actually you need more surface area, that's why we try to maintain 50% liquid fill, but separator can be different. You can design separator for different liquid percentage also. Okay, and this is for calculation for two phase separator only. So liquid retention time in two phase separator generally as follows, like if we have more than 35 degree API, American Petroleum Institute gravity, then typically 1 minute retention time can be okay. 20 to 30 degree 1 to 2, 10 to 20 degree 2 to 4. You see the viscosity, actually heavier oil is this one. Okay, so heavier oil means particle settlement rate will be lower. Okay, because heavier oil means density, viscosity will be different, because of viscosity and density other part different, so particle will not settle quickly. Okay, liquid will not move up or oil will not go down, so that way it will take more time to settle. So you are giving more time, like 2 to 4 minutes. Above 35 degree API, very light oil, so in that case you are giving very low retention time, so that is 1 minute. And retention time formula, normally TR will be volume of liquid storage in a vessel, divided by liquid flow rate. Okay, so this is the formula for retention time. Okay, for most application TR will be 3 seconds to 3 minutes. Foaming crude will increase TR or retention time to 4 times. So if you have foaming liquid, so in that case retention time you have to increase because foam will not allow to separate gas and liquid quickly. Okay, so for foaming of crude, TR retention time will be high, about 4 times. If you don't have foam, let's say 3 minute to 3 minute or 2 minute, 4 minute you can give, but foam is there, that means you have to increase. Although you may be using defoaming plate, but still you need higher retention time, so that liquid and gas will be separating properly. Droplet size. So droplet size is also very important, because you can remember the VT formula. Okay, dm is your droplet size. So a larger droplet size will be separating quickly. Okay, in our case normally we will be using 10 to 100 micrometer or micron. Okay, 100 micron the size we will consider for our calculations. Separator removes about 10 to 100 micron size. Gas capacity calculation removes 100 micron, and gas scrubber removes about 500 micron. Okay, so gas capacity in our calculation will take like 100 to 200, within that range for calculations. So I'll discuss later what is gas capacity calculation. Okay, settling formula. We have seen one settling formula, Vt equals 1.78 into 10 power minus 6 del Sg specific gravity difference, and dm square divided by viscosity. Okay, you have to remove this formula, because many times I'll ask what is the relationship between viscosity and Vt, or Vt and dm, or Vt and Sg. Okay, many times if I change Sg, what will be the value of Vt? Okay, it will be increasing, decreasing, how it is related. So if you are not remembering the constant part, still you have to remember the other part, del Sg, dm and mu relationship with Vt. Okay, so del Sg is specific gravity, and it is related to 1, water equals 1. Dm, droplet size in micrometer or micron. Okay, mu is the viscosity, Cp. Okay, now you draw this picture, gravity, and you are getting drag force, because when gas is moving up, gas will be trying to move the particle up, because it will be dragging. So that's why drag force will be upward, and gas if g, the force due to gravity Fg we are writing. So for low Reynolds number, Stokes law, if we are assuming for, so you have to remember this one, for Re less than 1, actually this formula for Re less than 1. Okay, so if we derive this formula, it will be like this: Cd equals 24 by Re. Again it will be coming from Stokes law. Okay, flow around the particle, we are assuming laminar flow. There is no turbulence is created, very smaller flow velocity is there. So this is laminar flow. Okay, this criteria you should remember. So drag force Fd equals Cd, drag coefficient, drag coefficient Cd into A rho g v square by 2g. Okay, A means area of this particle. Okay, so this area will be pi by 4 d square. So this area, particle area. Okay, so if I put Cd equals 24 by r into A means pi by 4 d square rho g v square by 2g. G means gravitational acceleration due to gravitation. Okay, so this one, if we simplify, 24 by Re formula is that Re equals 3 pi mu dash dV. This is Stokes law. Okay, so you should remember this formula is used here. So rho g dV g mu dash pi d square by 4 rho g v square by 2g. Okay, and buoyancy force, because of gas is moving up and it is giving buoyancy force. So buoyancy force will be rho liquid minus rho gas. Okay, the density difference, pi d cube by 6, the particle volume. Okay, droplet acceleration, let's assume droplet acceleration equals 0 and terminal velocity is Vt. Okay, so finally you are getting 3 pi mu dash dV equals rho L minus rho G pi d cube by 6. So dV actually dVt, Fb equals Fd implies. Okay, so finally you are getting Vt equals rho L minus rho G by 18 mu dash d square. Okay, once you convert all the units like mu dash equals mu 2.0881 D equals dm 3.281 10 power minus 6. This is micron. Okay, this is D is feet. Rho L equals 62.4 Sg. Rho G equals 62.4 Sg. Okay, Sg is specific gravity related to water, already given up. Okay, so if we put all these values here, so finally you will get the equation Vt equals 1.78 10 power minus 6 Sg dm square by mu. Okay, so you should remember this formula. Okay, so this for Stokes law Re less than 1, but in practice this equation does not valid in oil and gas system, so you have to modify this equation. So what is the modified form? Okay, so in practice the Stokes law does not hold. So in this case modification is like this: CD value will be 24 by Re plus 3 by Re power half plus 0.34. Okay, CD value is changed. Okay, now terminal velocity also be changed, got changed. Vt equals 0.119 rho L minus rho G dm by CD. So how to get this one? Because remembering sometime this equation will be difficult because there will be some constant, and those constants sometime very much confusing. Okay, because of this field unit. Now how to derive it? Fd drag force equals CD A rho G V square by 2G. Okay, you have learned this one. So CD pi by 4 d square particle diameter rho G V square by 2G. Okay, particle velocity. Now Fd equals Fb buoyant force, so it will give CD pi d square by 4 rho G V t square terminal velocity, because when Fd equals Fv, so I am putting terminal velocity 2G equals CD pi d square equals rho L minus rho G pi d cube by 6. In previous lecture slide we have seen pi d cube by 6 the volume. Okay, so therefore Vt becomes 6.55 rho L minus rho G d by CD per half. Okay, now if I put d equals dm converting unit 3.21 into 10 power minus 6 d in micron, then Vt becomes 0.0119 rho L minus rho G divided by rho G dm by CD. Okay, so this formula you should remember. Normally this formula will be using, not the previous one. Previous one just basic to give idea how particle settlement formula will be working if Re less than 1, but in this case Re more than 1, so you have to use this formula.